This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A roof pitch can change the structural job of the ridge before anything looks dramatic in the field. That is the central idea I want you to carry through this lesson. A roof that rises 3 units for every 12 units of horizontal run sits on one side of a California prescriptive framing threshold. A roof that rises just under 3 units for the same run sits on the other side. The difference is not a matter of calling the roof a little flatter. It changes whether the ridge, hip, and valley support can remain a prescriptive framing interface or must be designed as a structural beam. Pitch is simply rise, compared with run. When I say 4 and 12, I mean the roof rises 4 inches for every 12 inches of horizontal run. I do not use the length of the sloping rafter as the run. The run is the horizontal projection. That distinction matters when I read plans. Check a framed roof, estimate roof area, or coordinate a roofing material that has its own minimum slope. I also separate pitch from the finished roof covering. The framing threshold and the roofing material threshold are related to the same geometry, but they answer different questions. One question asks how the rafters are supported and tied. Another asks whether a particular covering and underlayment method can shed water on that slope. Mixing those questions is how a contractor can make a roof look framed while still carrying the wrong structural detail or the wrong weatherproofing assembly. Before lumber is cut, I want the slope written in plain language. Suppose the plans call for 2 1/2 and 12. I immediately hear 3 separate decisions. The roof is below the 3 and 12 structural threshold. Asphalt shingles are still above their absolute 2 and 12 minimum. The slope also falls inside the 2 and 12 to below 4 and 12 range that requires the specified double underlayment application. The pitch decision chart puts those zones side by side. Below 2 and 12, asphalt shingles are not permitted by the rule covered here. From 2 and 12 to below 3 and 12, the roof is in the asphalt shingle double underlayment zone, and the ridge, hips, and valleys must be treated as structural beams. From 3 and 12 to below 4 and 12, prescriptive ridge board framing may be used when the other framing conditions are satisfied, but the asphalt shingle underlayment is still the double application. At 4 and 12 and steeper, the low-slope double underlayment rule no longer controls the asphalt shingle assembly. That chart also shows why memorizing only one number is risky. 3 and 12 controls the structural framing threshold discussed in the residential code. 2 and 12 controls the absolute minimum slope for asphalt shingles. 4 and 12 marks the upper edge of the special double underlayment range for asphalt shingles. I keep those numbers in order as structure at 3, shingles start at 2, and standard underlayment returns at 4. The words matter as much as the numbers because each threshold answers a different field question. Now picture an addition roof that must tuck below an existing second-story window. A shallow slope may solve the clearance problem on the elevation, but it can create a new framing requirement at the ridge connection and a new underlayment requirement over the deck. I do not let the architectural fit hide the structural and drainage consequences. That is a general B supervision habit. Every geometry change gets checked across framing, roofing, drainage, and safety before the crew commits materials. The ridge board and ridge beam are not 2 names for the same piece of wood. A ridge board is a non-structural framing interface. It gives opposing rafters alignment and a nailing surface. Under the prescriptive condition covered here, the roof must be at least 3 and 12, and the rafters must be tied so their outward thrust is resisted. A ridge beam is structural. It carries vertical roof load and transfers that load to supports. When the pitch is less than 3 and 12, the ridge, hips, and valleys supporting the rafters must be designed as structural beams. I stop at that boundary because beam sizing, point loads, posts, foundations, and connection design belong to the approved plans and the responsible design professional. The easiest physical picture is an upside-down half-open book. The covers act like the roof planes. push down at the spine and the lower edges want to spread. A tie between the lower edges resists that spreading action. A solid support under the spine changes the load path by carrying the peak. The comparison is not a design method, but it makes the distinction memorable. A board lines up rafters, while a beam carries load. The supported effect behind the low slope threshold is increased outward thrust as the roof becomes shallower. If a contractor substitutes a thin ridge board where a structural beam is required, the problem is not cured by adding nails and hoping the sheathing makes everything act together. The load path, shown on the plans, still has to reach proper vertical supports. That is why I treat a low slope ridge detail as an early coordination item, not a late framing inspection surprise. The ridge interface has several prescriptive details worth checking. The ridge board must be at least 1 inch nominal thickness and at least as deep as the cut end of the rafter meeting it. Opposing rafters cannot be offset by more than 1 1/2 inches. They also must be connected with the required collar, tie, ridge strap, or gusset plate arrangement identified by the applicable framing provisions and plans. Hip and valley rafters carry intersecting roof framing, so the code details are different from a casual filler board. They must be at least 2 inch nominal thickness and cannot be shallower than the cut end of the rafters they support. I am not sizing the member from that minimum. I am checking that the basic interface is not obviously undersized before the work is covered. The framing interface table separates 4 checks. At the ridge board, I check nominal thickness and depth. At opposing rafters, I check alignment and the permitted offset. At hips and valleys, I check nominal thickness and supporting depth. At a wide chimney or penetration, I check whether the cricket threshold has been crossed. These checks belong together because roof geometry concentrates mistakes at intersections. Imagine a framing crew that lays out one roof plane first and discovers the opposing rafters land 2 inches away at the ridge. Shifting the rafters without resolving the layout may exceed the permitted offset and can create a poor connection. The right move is to stop, compare the plan geometry, verify wall and ridge layout, and correct the cause before sheathing locks the mistake in place. A small mismatch at the ridge often points to a larger layout issue somewhere below. I also watch the transition from full-length rafters to jack rafters at hips and valleys. A hip or valley is not just a visual line in the roof. It is a framing interface receiving multiple members. The general B task is to recognize when the field condition matches the plans, when the minimum framing details are present, and when the condition needs the designer rather than a job site improvisation. Slope also controls whether a roof covering can be used and how the underlayment must be installed. Asphalt shingles require at least 2 and 12. That is an absolute minimum for the rule in this lesson. Calling a roof nearly flat does not create an exception, and adding more nails does not turn shingles into a low-slope membrane system. From 2 and 12 to below 4 and 12, asphalt shingles require the specified double underlayment application. The sequence begins with a 19-inch strip laid parallel to the eave. Then, 36-inch sheets are applied, so each course overlaps the previous course by 19 inches. The geometry creates 2 layers over the deck rather than relying on a normal narrow lap. The practical effect is slower drainage on the shallower roof. Water has more opportunity to linger and move under laps, especially with wind-driven rain. The double application creates a more protective underlayment condition beneath the shingles. I do not describe that as permission to ignore the shingle manufacturer's listing or the approved project details. The code baseline, product instructions, and plans all have to agree. At 4 and 12 and steeper, the special low-slope double application is no longer required by the asphalt shingle provision covered here. Wood shingles and wood shakes have a different minimum. They require at least 3 and 12. I keep material rules separate because a slope that accepts one roof covering may not accept another. Consider a hypothetical family room addition at 2 and 1/2 and 12. The roofing crew arrives with asphalt shingles and plans a standard single-layer underlayment. The shingles are above their absolute minimum slope, but the underlayment method is wrong for that pitch range. I stop the installation before the roof is loaded with material, verify the specified assembly, and require the double application sequence. That prevents concealed noncompliance and avoids tearing off completed work after inspection, or leakage exposes the mistake. Overhang language is simple, but the interfaces are not. The eave is the low horizontal roof edge where water leaves the roof plane. The rake is the sloping edge at a gable. An overhang is the roof projection beyond the wall line. I do not memorize a made-up universal overhang depth because the supplied statewide rules for this lesson do not establish one. I use the approved plans and details. At an eave, pitch, sheathing, underlayment, roof covering, edge metal, fascia, and gutter coordination all meet at the place where water must leave cleanly. At a rake, the roof edge still needs a complete weatherproofing and finish transition, but it does not perform the same drainage role as the low eave. Calling every edge an eave can lead to a wrong detail being carried around the roof. The overhang also affects framing layout. Rafter tails establish the eave projection. Gable end framing and lookouts may establish the rake projection according to the plans. The important supervision habit is to verify the wall line, roof plane, and finished edge dimensions from the same control points. I do that before sheathing and finished materials make a correction expensive. A penetration interrupts drainage just as surely as an edge directs it. When a chimney or roof penetration is wider than 30 inches measured perpendicular to the slope, a cricket or saddle is required on the ridge side. The measurement direction matters. I measure across the obstruction in the direction that blocks water moving down the roof, not along the slope just because that dimension is easier to reach. The cricket belongs on the uphill side because that is where water approaches the obstruction. It divides and redirects flow around the penetration. I coordinate it before the roofing contractor arrives, because framing, sheathing, flashing, and roof covering all depend on that shape being present. A 42-inch chimney without the required cricket is not a flashing detail that can be casually solved at the end. A parapet roof changes the drainage problem because the perimeter can trap water. Primary roof drains handle the normal drainage path. The plumbing sizing rule in the supplied material uses a maximum rainfall rate of 1 1/2 inches per hour in designated areas as a baseline. The exact project design still comes from the applicable plans, rainfall data, and plumbing calculations. The secondary system is not extra capacity that can be traded away by making the primary drains larger. When a parapet or similar perimeter construction can entrap water, secondary emergency overflow drains or scuppers are required. The secondary system is sized independently, treating the primary system as though it has failed. The drainage comparison table makes the independence clear. The primary system carries routine roof drainage and is sized by the applicable rainfall and roof area calculation. The secondary system provides an emergency path when the primary path cannot discharge. For an emergency scupper, no opening dimension can be less than 4 inches. Oversized primary drains do not erase that separate requirement. The bathtub comparison works because a parapet roof is a contained basin. The primary drain is the normal outlet. The emergency overflow is the separate opening that limits how deep the water can become if the normal outlet is blocked. The comparison is not a sizing method, but it fixes the logic in memory. 2 paths, 2 jobs, independent capacity. The consequence chain is straightforward. Debris can block a primary drain. Water can then pond on the enclosed roof. Added water load can increase deck and framing deflection. A deeper low spot can collect still more water, which can further increase load and deflection. The secondary overflow path limits that accumulation before the condition develops into structural damage or possible failure. I say possible because the actual outcome depends on the roof structure, rainfall, duration, and blockage. But the risk is real enough that the overflow system cannot be treated as optional. During framing and rough coordination, I verify the secondary opening is actually framed, that its elevation matches the plans, that its path is independent, and that the minimum opening dimension is maintained. I do not approve a field change based on the argument that the primary drain is huge. The emergency system exists for the condition where that primary path is not working. Roof geometry also changes exposure, but the fall protection trigger depends on the operation and project type, covered by the safety order. For residential type framing, positive fall protection is triggered when an employee is 6 feet or more above the grade or floor level below while working on top plates, joists, rafters, trusses, beams, and similar framing surfaces. For residential type roofing, the trigger is also a fall distance of 6 feet or more. The supplied rule applies across the residential roof slope range, including low slope and steep roof work. I do not carry an outdated 15-foot residential framing habit onto a current job. Non-residential roofing is covered differently. The supplied material identifies a general trigger of more than 20 feet for the commercial roofing operations described there, subject to the applicable safety order, work method, equipment, and site conditions. I do not use that commercial threshold for residential framing or residential roofing. The fall protection table separates the 3 categories. Residential framing is 6 feet. Residential roofing is 6 feet. Non-residential roofing is generally more than 20 feet under the cited commercial roofing provisions. The correct first question is not just how high the roof is. I first identify the operation and the type of project, then apply the proper safety rule and approved protection method. Imagine a contractor moving a crew from a commercial roof to a townhouse project. The roofers know how to work, but the regulatory category has changed. Carrying the commercial trigger into residential work would leave the crew exposed and the contractor out of compliance. I reset the safety plan before work starts, not after someone is already on the roof. I want to close the technical lesson with a field sequence that keeps these rules connected. First, I read the rise and run from the plans and confirm the horizontal run is not being confused with rafter length. Second, I compare the pitch with the 3 and 12 structural threshold. If it is below that line, I look for engineered ridge, hip, and valley support and a complete load path on the plans. Third, I compare the pitch with the roof covering rules. For asphalt shingles, I check the 2 and 12 absolute minimum and the double underlayment range below 4 and 12. For wood shingles or shakes, I remember the 3 and 12 minimum covered here. Fourth, I inspect the framing interfaces, ridge board thickness and depth, rafter alignment, permitted offset, ties, and hip or valley member dimensions. Fifth, I trace water from the high point to the discharge point. I look at valleys, eaves, penetrations, and parapets. A penetration wider than 30 inches across the slope gets the required ridge side cricket. A parapet that can trap water gets an independent secondary overflow path, and an emergency-scupper keeps at least a 4-inch opening dimension. Sixth, I identify the operation before selecting the fall protection trigger. Residential framing and residential roofing use 6 feet in the rules covered here. Non-residential roofing has a different general threshold under its own safety order. That sequence is how I keep a roof from becoming 4 disconnected inspections. Here's the memory connection I use. Pitch chooses the path. It chooses the load path at the ridge, the water path under the roof covering, the drainage path around obstructions, and part of the work plan for safe access. The approved plans and governing requirements still control every project, but that single phrase helps me remember what to inspect when the roof geometry changes. Official preparation resources identify roof framing as a key area within the general B scope. The useful skill is not guessing an isolated question. It is recognizing that one slope ratio can affect structure, material selection, weatherproofing, drainage, trade sequencing, and safety at the same time. There is an audio practice quiz for this specific episode on roof pitch, drainage, overhangs, and framing interfaces. I made it audio-based with the questions read aloud and your answers entered by tapping, because I know you may be studying while driving, working, or moving between jobs. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. Subscribe so I can help you stay on track through every episode until you get your license. I am rooting for you, and I want each study session to move you one clear step closer.